All right, welcome everybody to Foundations of Programming, day 9. It's kind of funny. Today when I opened up one of the videos I uploaded, and then I noticed something. So I opened up all the other ones. I start every recording the same way. I'm like, all right, guys, welcome back. All right, guys, welcome back. And it was kind of funny just hearing that line over and over again. Every time I opened up a new video that I was teaching, is always like, all right, guys, welcome back. I hate hearing myself in recordings, but let's go ahead and continue. Yesterday, we were working on the Python crash course. We stopped a little bit right before working on functions. I didn't want to start a different subject if I knew I didn't have enough time to really kind of talk about it. But we finished the number guessing game, and then and now we're going to talk about functions. Um, just like before, just have a Python file opened up that we can kind of code along with as we talk about the different subjects. Um, and functions, they're still the same concept.
You guys bring me
As
that water bottle too? I left
Tim, you are muted. I mean, you're not muted, so let me go ahead and mute you real quick. No big issue. It's okay, it happens. But in JavaScript, we're able to create functions, and you can do the same thing in Python. And honestly, Python, the one of the things that make Python such a strong language is it's the fact that it's very object oriented, or oh, it's kind of funny because object oriented programming oriented. If that makes sense. It's very heavy with object oriented programming, and a lot of people utilize it for that too. Very similar to Java. Java is all object oriented programming, but Python is so it's very flexible. You can do a lot with Python. And we're gonna go ahead and create some functions here. Now in JavaScript, you might be familiar with something like function, where it's like do something, right? Something like this, right? uh, Using the function itself, or you would declare like I'm very rusty with JavaScript. I do apologize. Like const do something. It's equal to open and close parentheses, curly braces, something like very similar to this, which is like the exact same thing. You're creating a function. All right. I tend to forget my JavaScript here and there. I'm about Python, but in Python, we don't use the word function. We use the word define, right? Or more specifically, the abbreviation of define, right? We're trying to define a function, right? So to declare the start of a function, we're going to use the declaration of def, right? For define, right? After the declaration, you're going to, just like JavaScript, you're going to give it the name of your function. And this example will be sum2, right? Sum to open and close parentheses, still very similar to JavaScript. The biggest difference here is the fact that we're not using function, we're using define, right? To specify the start of a new function, right? Still with the JavaScript analogy, we would essentially open up curly braces and then we would add our function. We don't do that here, right? Just like everything else I've done so far, when you're ready to start some kind of code block, you're going to use the colon, right? And then proceed to the following line, which will automatically indent it for you, specifying that this is a new block of code that's nested within the sum2 function, right? So that's how your interpreter is able to identify where this function starts and where it ends, right? By the indentation of your code. Um, and just like JavaScript, right? So we have the parentheses, and then you can pass in parameters here as you'd like, as many parameters as you want. But this function here will not take any parameters, and the only thing it's going to do is just go ahead and we're going to hard code a total, which is going to be let's say 2 plus 2, and then we're going to say return total, right? Return total. Now, when we're ready to use this function, we're going to call it sum2. And we're going to specifically wrap this around a print statement so we can print out what's returning out of this function. Now let's go ahead and run this. Python demo.py, and we see we get 4. right? Now, what happens if I remove this return total line here? What's going to happen? What do you think I'm going to get if I remove line 123? Any wild guess? If I remove line 123, what's going to happen to this function?
Well, you're not printing anything. You're not console logging dot anything. So I guess it probably wouldn't return anything.
Well, why won't it print anything out? Because I'm if I
Oh,
were to comment this out, right,
okay.
this function would automatically add up 2 plus 2 into the variable total, and then
Hmm.
I'm printing the function here on line 125, right? We were able to see that before when I had the return total, I was able to print out 4. But what's going to happen now that I commented out? What's going to be printed out? Is anything going to be printed out?
I
And
mean,
if so,
I would just say nothing's being returned. So I'll just say like a no value or something like that. So nothing's gonna be printed out, like
yeah,
none or null
that's
or
a
something.
that's a very good guess. Exactly, right? So nothing's being returned to me. So when this print statement calls to print out this function of sum 2, because nothing's being returned from the function itself, the value of this function is none, right? So even though I was able to do some form of arithmetic within this function, the rest of my code does not have access to anything that happened within this function unless I return it, right? Um, so if I do something within this function, what is this called? Do you guys know, or what type, or what this is called when you do something within a function or outside of a function? There's a specific term, which I'm trying to see if you guys are aware of this term or
You're
not.
talking about scope.
Correct. We're talking about scope here, right? So because this function, the total is equal to 2 plus 2, is within the local scope of this function, right? If I want the global scope, which is essentially the rest of my code, to have access to the total, I need to bring this total outside of the function by using a return statement, right? So that way I can actually use it and print it out outside of the function itself. Um, and if I wanted to maybe save the result of this function into a variable, that would work as well, right? Um, if not, then that if I try to do something like this where this function wasn't returning anything, and I try to say result is equal to sum 2, well, whatever is coming back from this function, there's nothing. It's going to be none. So result is going to equal to none, right? So it's very important, right, that you are actually returning something. People always forget this, and they're wondering why is my function not working, right? Which is why I have to bring it up. Now, right now we hard coded it, but we're able to add what we call parameters, right? And you've probably heard the word parameters and arguments used interchangeably. You can tell me the difference between arguments and parameters.
Arguments which you use when you're actually calling it in line, and parameters are used what you code it, or is it the opposite?
That's correct, Tim. Right. So parameters is what we call uh, these items when we're defining the structure of our function. Right. So the first parameter will be num1, and the second argument will be num2. Right. We're setting the parameters of how the function should work. Right. That's why we call it parameters. Now, when we actually have to use this function, it changes its name, right? We call it something different. But people tend to use these names interchangeably, and that's just something I wanted to point out so there's no confusion later on as we progress through the Python code, right? But Jesus Christ, there we go. When we're ready to call this function, and we want to add some items in the location of what the parameter should be, That's called arguments. All right, we're gonna pass an argument, and in this situation, we'll make this one 5. The first argument will be 5, and the second argument will be 10, right? So at this point, these are now called arguments, but in the definition, these are parameters, right? They kind of think of it like the left and right limits of what this code should be taking, right? Right here. Turn total. Let's print out results. Sorry, my code's a little wonky right now. There we go. Let me get 15. Right, so it is called parameters when being defined, but it's called arguments when you're actually calling the function. Right, functions. Answer.
So in JavaScript, you can access if you're calling a function, you can access a variable that was designed or declared outside of that function's scope. Can you do that in Python, or do you have to pass it as an argument?
That is a good question. You have access to it. But it won't work the other way around. So you do have access to it, but it won't work the other way around, right? So if I declare something within here, if I say num is equal to 5, and then I try to call this outside my function, print num, it won't work, right? Unless I'm returning it, right? But yes, you can declare num is equal to 10 and then use it in here, right? Was that your question?
Can you modify it within the function that you're writing? Because I'm
Yes.
trying it on my own, and I'm getting an error saying that cannot access local variable and then the variable name.
I'm pretty sure, man, at least I'm super rusty on this. Let's check it out. Let's go ahead and comment this out. And let's say num is equal to 0. We're going to create a function, increase num. And then we're going to take num plus equals 1. Return num. I see what you mean. Okay. Yeah. We're gonna have to pass in the argument. I'm assuming I'm getting confused with classes here, but yeah, we're gonna have to pass in the argument in here to get access of that function within the function itself, right? So it's only gonna take whatever arguments or parameters we set here. Does that make sense, Tim?
It does. It's
Yeah.
just a radical departure from what I'm used to, so I wanted
Yeah.
to make sure that I wasn't just messing this up with my lack of experience in Python.
No, it's okay. I was getting confused myself with a different topic. But yeah, we're not gonna be able to do this. And that's okay. Yeah, so functions, right, back to the lecture. It allows us to kind of reuse code without constantly retyping it, right? It helps us to manage the complexity of our code, and then just reuse it. So it looks much neater. Once we create a function, we kind of just like close it out, so we don't have to look at it. But this could be like long lines of code to handle one complex problem, right? Especially if you're going to constantly be doing something. There's no point to repeat yourself, right? And it brings us back to a specific method or methodology that we like to talk about, which is the dry method, right? Which is don't repeat yourself in code. If there's a way to kind of automate it or reuse some code, then you want to do that. If you can create a small little function for something that you're going to be doing like 50, 100 times, why not just create the function and save yourself some time, right? So always stick to the dry method. Don't repeat yourself. If you're able to make reusable code to handle this specific functionality, then go ahead and do that. All right. Now back to the function scope. We talked about the scope here, and this is a very good kind of point here. This is what we call the global scope, right? This is the rest of our Python code. And then we get to the definition of this function. And as you see, we weren't able to use num within the function. But the moment I add it within the parameter, it now kind of gets some color here. You can see the life bringing to this function because it now has accessibility to num. For everything within here, it's going to be our local scope. And one thing to take into account when working with Python is how code is written, right? Does anyone want to take a wild guess of how your machine is going to read your code? Like, for example, if I make a function here at the very bottom of my screen, can I access it above?
No.
Why not? Can JavaScript do that?
Yes,
Do you know why?
because I assume that Python reads the entire reads from top to bottom instead of reading the entire file.
Yeah, so Python, you're absolutely right. It's going to read from top to bottom, right? Which is a little bit, it's similar to JavaScript, but JavaScript is a little bit different, right? Because JavaScript has something called hooks that you don't visually see. But JavaScript is able to, even though I declare this function down here, I'm actually able to call it somewhere above. JavaScript is smart enough where it's able to go down here and hook the function that you define somewhere else and bring it up. Right, so all like the definitions of functions that are being declared anywhere around your code is immediately brought up using some form of hooking, right, to the top of your file document. So if you try to use a function at the very top of your code that you define at the very bottom, it'll typically still work. And that's just really the difference between JavaScript and Python. But Python won't do that, right? I have the function here, but if I try to do increase num here, we're going to get an error, right? Because it's not defined yet. So it's very important to be aware that if you're used to JavaScript being able to identify the function before, Python won't work that way, right? So it's going to work from top to bottom. So it's very important to know if you want a function to work, you might want to define it before you get to the different part of your code, right? Do you have any questions on the scope and then how the functions are read or whatnot?
I do have another question. I'm sorry.
Yes,
Maybe you covered this before. When you're passing an argument into a function that you've created, the argument is a variable. So when you call it, you don't need any actual arguments. So you define it using your parameters, right? Like we did above. We took the global variable and went to pass it into the string as a parameter. And then when we called it, we used it as an argument. Can I pass the literal value of a variable so that I don't have to call it with an argument and it still pulls from the global variable?
I'm struggling to understand what you're asking. Could
All right,
you?
sure. Scroll up.
Okay.
Where's the one with the num? Did we delete that function?
The number here?
Oh yeah. Could you uncomment that out?
Yeah.
All right. So no, that's not the right one.
Are you referring to if instead of adding 5 here, I could do num?
No, so I want the value that you defined as a global variable num equals 10. I want that 10 to be passed into that function.
Oh, I'm assuming you're talking about a default parameter.
Yes, the default parameter using a variable.
Yeah, you definitely can, right? So, for example, here we have increase num. Let's go ahead. Actually, just change this.
Would I just say in the argument, whatever I want to call it equals num?
Correct. Right. So it would be define some num, and then you could do like num1, but then you could say num2 is equal to 10, right? Now,
Well, so I don't want to hard code it as a value. I want to use the variable I defined as num earlier, because that variable can change and maybe it's part of a multi-step process. Like I define a variable, I manipulate it in several ways, and then I want to pass whatever that variable currently is as an argument when it's called by default.
Oh, that's actually a good question. I've never actually tried that concept. I would assume you could, right? Yeah. It looks like you definitely can. I don't get errors here. Let's give it a try. You definitely can give a default. I never thought about dynamically putting a variable here. Let's say sum is equal to num1 plus num2. And then if we return sum, we can print sum num passing 5, and then that's it. We'll pass in 5 for now, right?
Yeah.
So by default, num2, it already has a default, which is 0. So this should return to me 0. But then if I say uh, num plus equals 5, and then I try to run this again, then this should give me a 10.
Yeah, just get a 5
Um,
and a 10.
yeah, and it looks like it did not work. It gave me 5 again. It took, when declaring this, it assigned it a 0, what it looks like. It interpreted this as 0, right? So it kind of goes, I can see why it's working now. Going back to how your Python code is being read, right? Unlike JavaScript. When this runs, it runs this line and says, okay, I see here that this variable num is 0. All right, cool. Let's go, move on forward. I'm gonna declare a function here. In this declaration, it seems that they want me to set a default here for num2, and this default is going to be the value of whatever num is, which is cool. We do that. And that's how this was defined. That's it. That was the first. That's when it was defined. It won't change. It doesn't change because it doesn't read this again. It does not come back to this, right? So when it gets to this line, it sets not necessarily this variable. It sets the value of the variable, which is 0. So by default, num2 is set to 0, and that is it. It won't run this again. The function was declared here for the first and last time, and it was by default set to 0 because that's what the value of num was at the time that it was declared. So when we get here and we run the function, it's going to give a 0. It changes num, right? We change num, but this doesn't matter. These aren't linked to each other from what it looks like. It just used the value of num at the moment that we declared it to set it to num2. But they're not linked in any shape, way, or form from what it looks like. Does that make sense, Tim?
It does. Can we use that function and then say num plus equals some num 5 and change it that way?
Are you saying, could you say that again?
So can, instead of num plus equals 5, can you do num plus equals and then call some num with an argument of 5? And does it do the same thing?
So this,
Because you're returning some num. So
yes,
it should be plus
this
equal.
this will return
Mhm.
5. So this is gonna set num to 5, but that does not matter. The declaration of num2
It's
is
hard coded.
still hard coded, correct? There's no link, right? If we run this, you can see that this is the same because this is gonna return 5. This is the same as just saying plus equals 5. Nothing changed, right? In the definition of the function itself. This was defined once and read once, and that's it. The first time it's being read, it took the value of whatever num was and set that as a default. This is the same as reading num2 is equal to 0. Right? And that's it. These two are not linked permanently. It just takes the value that this variable has at the moment of the definition and sets it to that. Make sense?
Yeah, it does. Thank you.
No, thank you. That was a very good question. No one's ever asked that, so it was nice to see that. Variables in a function only exist while that function is executing, and you guys kind of already saw that. When the function is done, those variables go away. So you can't try to print some afterwards. like saying print sum, because this won't work, right? This only exists within the function call. I can't print it outside of the function when it's not running, so I don't have access to that. We saw that we were able to set some default arguments within our function. We talked about how that's set and how those can't really be changed later on dynamically. We can change them manually if we wanted to, by just adding that argument in its place. Instead of setting a default, it's going to just override that default and then move on with the function, right? So the default is there in the event that you have something that's usually very consistent, that stays the same. You don't have to continuously pass in that argument, but then you also have the ability to override it in the event that something does change, like we did now, right? All right. Now, the next one we're going to talk about is going to be doc strings. So doc strings is a format, it's a form of commentation, right? So as you saw here, when I wanted to comment something out, it uses the hashtag, whereas you see, I believe JavaScript uses the 2 forward slashes. You might see that HTML use something like this, where it was like /**, /**. Different types of languages have different ways of commenting things out. Python uses a hashtag, just comment out an entire line, right? But let's say you have multiple lines of code that you want to comment out. Let's say like lines 146 to lines 148. You would essentially have to add a hashtag to every line of code that you're trying to comment out. Or what you could do is you can put them between triple quotation marks, right? Triple quotation marks will allow you to add a commented out piece of code, which is known as a doc string, right? These are very specific. They're usually used to document what your code is doing, like to be straightforward, mainly functions, right? Functions and objects and classes, right? Because it can be a little confusing sometimes, especially when we have a very long function being declared, to show it to a new developer and have them understand what the function is doing. So we like to use doc strings or just comments in general to document what your code is saying, right? You're not going to be the only person working on your code. You're going to have other people that will be reading it, maybe, but debugging it, improving it later on if you ever leave the company, or honestly, just yourself. I had an interview where they asked to see a personal project of mine, and I had not opened or even seen this personal project in months. And there was a specific part of my code that they wanted to see, and they're asking me where was this happening. Well, I have all this code on this one file, and this one file was like 200 to 300 lines long of code with I don't know how many different functions set up. And I sat there for about 15 minutes going through all my code until I was able to find where this specific function was happening so I can show that to the interviewer. Long story short, I did not get the job, right? Because I wasted like 15 minutes of this interview just looking for this piece of code, and it wasn't very professional, right? So it could have been avoided if I'd used better documentation than what I had. I had no documentation, as a matter of fact, on this personal project, because I didn't really take it that seriously to begin with when I was first coding. But you tend to forget a lot when you go some time without coding, and it's gonna happen. And I say this because once you guys graduate from the cohort, which by the way, the current platoon right now, going through, graduates tomorrow. So if you guys want to see their graduation presentations, I will send out the links. But the students that are about to graduate are the same students that came through FOP. Out of the 14 students in his cohort, I want to say half of them came through Foundations Programming. So I'm pretty proud of that. Every single person that came through Foundation Programming passed, and is going to graduate. The 2 people that were in their cohort that are not going to graduate were not a part of Foundation Programming. So I just want to say that. But they'll graduate tomorrow, and you can see their personal projects if you want to, which is really cool to see what you will be doing in the next 4 months, which is awesome. But I'm sorry, I'm going on a tangent here. But what was I saying? Yeah, the documentation, right? So I didn't take it too seriously while I was doing my personal project, but it would have helped me out, and maybe it would have landed that job. I forgot what company it was that I was interviewing. So make sure that you have good documentation, whether it's the doc strings using these triple quotes or just a simple line, just telling you, remind you of what this function is. Hey, this function is supposed to be a GET request to this API to grab this, right? Something as simple as that could lead you to the right direction, and avoid an embarrassment that I went through. All right. Next is gonna be the first assignment for today, which is gonna be the Hailstone.py. The Hailstone.py is a little bit confusing. I'm not gonna lie. Every time I talk about it, I think it's Hailstone, or what's the other one? Yeah, I think it's Hailstone that always confuses me. It's one of these that I really hate. All right, so a Hailstone sequence, it starts with some positive integer, right? If that integer is even, then you have to divide it by 2 to get the next integer in the sequence. Right, so as of right now, you have this function called Hailstone, right? And they should take some kind of number. Let's say it's 10 to keep it simple. This function should take this number, divide it by 2 to get the next integer in the sequence. So we should be able to divide 10 by 2 to get the next number. If it is odd, then you multiply it by 3, right? So if this is even, then we divide by 2, or if it's odd, then we multiply by 3. So divide by 2 if even, or divide if odd. So using these instructions, use your function that you're going to create to take in some number and do the following, right? So just take it one line by a time. So once again, if it's even, we divide it by 2 to get the next integer in the sequence. But if it is odd, then we multiply by 3 and add 1 to get the next integer in the sequence. Then you use the value you just generated to find the next value according to the same rules, right? Now, what is the point of this function? Well, you're trying to see how many steps it takes to reach the number 1, right? So this function should take a positive integer as the initial number of a Hailstone sequence and returns how many steps it takes to reach 1, right? So technically, you could keep going because you could reach 1 multiple times, but you want to stop your function the first time you encounter the number 1. If the starting integer is 1, then return the value. The return value should be 0, so that it takes no steps to reach 1, right? But if, for example, the starting integer is 3, then the sequence would go something that's similar to this. It goes 3, 10, 5, 16, 8, 4, 2, and 1. So then we have to return the value of 7 because that's how many times it took for us to encounter the number 1, right? So use the rules explained in the first paragraph to format this number to the point that you encounter the number 1 for the very first time and return how many times it took for you to reach this number, right? We'll take about 10 minutes to do this, and then we'll come back and we'll talk about it and then go on a break. Time is 6:08. Let's go ahead and come back at 6:18. All right, we're coming back from Hellstone.py. We're gonna get Jason here to demo his code. Jason, you are muted before you start talking. Just a heads up.
Is Kenny ready?
Do you hear me?
I'm not sure if Kenny is ready. He tends to be. Oh, perfect.
Did you
Yes,
hear
we can
me
hear you,
now?
Jason. Yes, Jason, we can hear you.
Okay, I did this kind of quickly, so I'm pretty sure I could, reformat it.
That's okay.
Okay, but I defined initially steps as being 0, and then I know if num is automatically 1, just simply return 0 next to the function. And then it pretty much did a while loop since we don't really know how many steps it could take. So while num is not equal to 1, if num is even, essentially divide it by 2, add 1, and then I just used a print num just to see where I was at. And then else, if num is odd, then it'll multiply it by 3, add 1, increment steps by 1, and then at the end it would return steps. So I did get 7 for the if the initial number is 3 as far as the number of steps. But I did it quickly.
No, I mean it looks good. Um, it's a fairly simple assignment, but what do you think about Python? Is it you like
Yeah,
Python?
I'm just more used to JavaScript, but I mean, it's just I don't think I think it's about the same in difficulty. I just haven't used it as much.
Yeah. Now, I mean, they're about the same, right? The hardest part is just remembering the syntax, which I mess up here and there too, but that's okay. It's other practice, but good stuff. Yeah, the reason why I kind of didn't want to spend too much time on it because we still got a lot. We're about a day behind. I'm not gonna lie to you guys. Uh, which is kind of ironic because you guys have probably been the best class by far and how receptive you've been with the information. But I think I spent a little bit more time explaining stuff than I have in the past. But as long as everyone's learning, it's okay. That's really what's important here. Let's go ahead and move forward. So we just finished the Hellstone.py. Now let's go ahead and continue. Let me move back to my code and bring it in. All right. So we talked about lists already temporarily or very briefly. My apologies, wrong word. But we talked about it very briefly. But in Python, when declaring a list, you use bracket notation as well, right? So a list, just like an array in Python, I'm sorry, in JavaScript, we use brackets. So we can say list of animals is equal to, and we're gonna start our list. A list is a mutable data type. Who can tell me what mutable is?
It can be modified.
Yeah, it can be modified, right? It's not set in stone. So we were able to modify the same list. Um, and I'll show you a little bit more exactly in depth what we mean by being modified. But we can have something like dog, cat, and bird, right? And this right here, when we print out, it'll print out the list of animals for us. Just like JavaScript, it also uses bracket notation. So if I want to grab the cat and just the cat, I would use index 1 to grab the cat. So nothing here has changed, right? We can use different data types within this list. It's not just restricted to strings or numbers. We can add a list within a list where if we print out index 3, it prints out the sublist within this list itself, right? If I wanted to grab an item within this sublist within this list, I would change. I would chain the bracket. So I would first want to grab the entirety of this sublist by calling index 3. This will return that sublist as we just saw. But now if I want to grab a number within here, I have to call another index. Let's say I want to go for the number 1. I would use index 0, right? So same thing like JavaScript. If you want to go within a list, inside of a list, you have to chain the syntax for whether it's a list or a dictionary or whatever it may be. Now, if I want to add a new element to this list, you're probably familiar with the dot push method, I think, for JavaScript. In Python, we call this append, right? We're gonna append something to the very end of this list. So we can say list of animals dot append. Let's actually remove the sublist so we can keep it to just list of animals. And I'm gonna add turtle to the end of this list. And then when I print the list of animals, I can see here that I now have turtle. So if I want to add something into a list, then I want to use the dot append method, right? Now, if I want to delete something from this list, there's a couple ways of doing it. If I want to just remove the last element within my list, I can say list of animals dot pop. And what this will do is this will remove the last item within this list. Doesn't matter the order, it will just grab the last item within this list. Right here, we're going to print out the full list. This will show turtle. I then use the dot pop, so it would remove it. And then I print it out again, and we'll see that turtle is no longer here. Right? I can even print out the actual pop itself, and it will show me what is popping. And we see here that it pops turtle very specifically. Right? So we can remove the last item within the list, or we can specify a specific item we want to remove by using, I believe it's going to be the del method. I can say delete list of animals at index 1. And if I print out list of animals, they should remove cat, right? So I can remove a specific index by using the delete method to get rid of the item at index 1. There's a different method, which I believe is called the
Are we sure that pop you can't throw in the index? Like, I know by default it takes off the last one, but if we throw through an index, would it act, kind of like that delete method?
I want to say it might, which is why I pulled this bad boy up. If we go to list, remove list items, I believe it's gonna be the remove item. Yes, we want to use remove. Dot pop method removes the specified index, so we could do the same thing, I guess, using dot pop. I'm more used to the delete method. But yeah, we could do that with pop. We also have the remove method. So there's a couple ways that you have to your advantage if you want to delete something, right? Here's the delete method as well. You can delete the entire list as well if you wanted to, or just clear the entire list. So a handful of different methods of doing this. The pop method can remove the last item or a specific index. Do I have any questions on the different ways that you can remove something in Python? Which one you want to do is honestly really up to you. If you just use the dot remove without specifying what you want to remove, know that this removes the first occurrence of a item in a list. So very similar to kind of like pop, where it removes the last item. The dot remove will remove the first item on the list. So you have some flexibility on here on how you want to remove things within a list. Sound good, Jason? You got any other questions? Right on. All right. Now, we are able to create a list, access item by the index. We were able to add things to a list, and then we were able to remove things from a list. Now, let's talk about slicing, right? Let me go ahead. I'm gonna make this list longer. We'll make a different list. Actually, we'll use the example on the slides. We'll say greedy is equal to hello and we can use greeting just like a list, right? And we kind of talked about this a little bit earlier yesterday, where we talked about how characters in a string are treated as a sequence the same way as a list is treated as a sequence of different things, right? Whatever they may be. Strings themselves are, in essence, lists as well, right? So we can treat greeting as a list, or we can treat greeting list as equal to hello, right? And we'll see how both of these work. But these are essentially the same thing, but they're not, if that makes sense. Because they're technically their own data type, but we can handle these the exact same, right? Now, if I wanted to slice, just like JavaScript, I can use the name of the list, and then I'm going to use the bracket notation. Now, the first part to the left of this colon is going to specify where I want to start in slicing in my list, where the right side is going to determine the end of my slice, right? If I don't add anything to the left or to the right of this colon, it's going to, by default, determine either the end or the start of your list, right? So, for example, let's go ahead and I'll specify a start point, but I'm not going to specify an end point. I'm going to say at index 2 to the start, and then I'm not going to say anything else for the end. And when I print greeting list with this specific index range, we'll see here that I get LLO. L being at index 2, and then everything to the right, right? So the left of the colon is the start, and the right of the colon is the end. And because I did not specify anything to the ending, it's going to grab everything from the start and onwards, right? And then vice versa. If I remove the start, but I added 2 to the end, it won't know where to specifically start. So just start from the very beginning because I didn't specify anything. But it will stop at index 2. Notice it's up to, but not including, right? Because we get the H and we get the E because these are index 0 and 1, but it didn't print out index 2. So it's going to be up to, but not including. So we were able to get the start or the end. We can give them both. Let's say index 1 to index 3, and we get E and L, but notice we don't get index 3, which is that third L. So it's up to, but not including, right? Once again. Do I have any questions so far on this slicing? All right. Well, if you guys recall yesterday, we talked about a method called the range method, right? And it took 2 arguments, actually 3 arguments. Can someone explain to me the arguments this range method took? What is the first one? What is the second one? And what is the third one?
The starting number, the stop, and the step.
Right. Right. The range method takes 3 arguments: the start, the stop, and the step. Slicing works the same way, right? The first argument within this bracket is the start. The second one is the stop. By default, it's going to increment or step by 1 when you don't add another colon. But I'm able to give it a third colon in here and specify a step. So let's go ahead and delete the start and let's delete the end. What do you think this is going to return to me?
LO.
L and O. Okay.
It might be HLO. I'm not sure if it includes the beginning by default.
I think it's going to be HLO, but let's give it a try. Oh, My bad. I added syntax HLO. Yeah. So right, HLO. Right. So because we didn't specify a start, it's gonna start from the very beginning. We didn't specify an end, so it will go all the way to the end. And we're saying that after each one that it gets, I want you to skip to the second one, right? So by default, it's 1. So we didn't see it, but it was just stepping over to the next one. But now, because it's 2, it's going to skip that first one and go on to the second. So it's going to go H, skips the next one, goes to L, skips the next one, and then goes to O, right? So the same way that the range worked, that we're able to specify the start and stop in this step, we can do the exact same thing. What do you think this is going to give me?
The entire string.
The entire string, right? So I get HELLO because we're not stepping over. By default, it's already 1. I just specifically typed it in, right? But by default, it's already set to 1. We're saying, hey, I want to go from the start to the end and then just increment like normal. Now, here's the cool part. What if I add a -1 to this step? What do you think it's going to do to me, to my string?
It's going to reverse it.
Yeah, it's going to reverse my list here. And I see that it's going to go backwards, right? From -1, right? It's going to go OLLEH, right? So it took this list and it reversed it completely. It got the entirety of it, but this time it did it backwards, right? So if you guys ever encounter a problem where it's like, reverse a string, or is this, I forgot what it's called. There's a specific term for when a word is spelled the same when it's backwards. You could do this to do the same thing. I think it's called like a palindrome. There we go. English is hard for me, but thanks, Tim. Yeah, so we can reverse a string in the same manner, right? Well, everything that we just did with this list can be done with greeting, which holds a string, right? The same way that we were able to work on the list. Notice that the string is now reversed, right? If I put this to 2, it'll put it back to normal. It'll get HLO, just like we did with the list, right? And so on and so forth. So we're able to slice our string in the same manner that we're able to slice a list. Cool? Do you have any questions on lists, how they work, how we slice them, how to add, how to remove, anything like that?
I guess I would say we're not actually, when you're printing, you're not actually changing anything. So if you reprinted greeting list and greeting, it would still be the same. Like
Correct.
after this one, after line 176.
Correct. We're not manipulating anything. We're just printing out. Right? Now, if I would have done something like greeting is equal to greeting, from this would change it. I would reassign something to this variable named greeting. Notice I said reassign, right? Because this is mutable. Well, what do you mean by that, Roger? You keep saying this word. What do you mean by mutable? Well, let's look at this. I have this string here called greeting. Did you know that you can check where in memory this variable is being saved? Did anyone know that? So let's go ahead and run this, right? I'm just getting my regular greeting. But what you can do is you can wrap around the variable with this keyword called ID. And when you print the ID of this variable, it's going to give you the memory address of this variable, right? And I want you to take a note of this. I'll even add it here to show you what the memory address is. Now, I'm going to go ahead and I'm going to, I guess, try to change what green is. And I'm going to say goodbye. This is the same variable, but I'm giving it something different, right? Let's print ID and greeting. And notice that these are two different addresses, right? It's the same variable, but they have a different value. But why are these numbers different? Well, because what happened was I didn't, change the string. This string did not change. Strings are immutable. They can't be changed. They're set in stone. What's happening here is this greeting is no longer pointing to the string of hello. We change what it was going to point to. It's now going to point to the string goodbye. This string did not disappear. It still exists. It's still the same string. We were not able to change it, but this name tag of greeting got reassigned to a different string, right? And this different string is somewhere else in my storage. Well, Roger, what's going to happen to the string hello? Well, what happens is what Python does periodically, it kind of runs almost like a trash collection, right? When something no longer has a way to be accessed, like the string hello, it no longer has a variable name that we can use to call it. What Python does, it puts it to make it available for collection. Think of it as your recycle bin in your computer, right? It puts it in a location where it's eligible for collection. And what Python is doing periodically is it runs some kind of trash collector that it grabs everything in the trash bin and just removes it, right? So essentially this ends up kind of being sent to the void and we never get access to it again. But we're not updating a string, right? We're not changing it. The string doesn't change. We create a new string, right? And that's what we refer to like when a string is immutable. You're not actually changing the string. You're just creating a whole new different string with the same variable name, right? It's like cloning your own child, right? And thinking that you just changed your child. You don't. You just made it a different child and called it the same name as your original, but they're not the same one, right? Kind of like the same concept. And kind of going back to lists are mutable, right? If I create a list here, list 1 is equal to 1, 2, 3. We can say print ID of list 1. And we get the ID here. Now let's go ahead and say list 1 dot append 4. And after I changed it, I want to once again print out list 1. Notice that these are the exact same thing. The list is still the same list. This is still the same thing. I was able to change it, right? It's mutable. It doesn't reassign it and recreate a new list, right? Lists are able to be changed, unlike strings. Now, you might be wondering, Roger, why do you keep harping on this? It's because you might get asked this question as a junior developer during the interview process, right? They sound very basic, but you would be surprised the amount of goobers out there that do not know this, right? That you would just draw a blank, right? People just struggle understanding basic concepts, just knowing the names and the syntax or the terminology of what they're doing, right? People tend to misunderstand when they think like, oh, getting a job these days in CS is difficult. It's not difficult, right? People think that they can just kind of get some kind of tutorial video on YouTube and learn how to code and then go get a job. You could have done that maybe 4 or 5 years ago, but because there's so many people now, like the quality of software developers these days is actually worse than you actually think. So people just don't know how to be software developers anymore, right? They don't understand basic concepts, right? It's almost like kind of being in the military again, right? The Joes just aren't the same anymore. Like people just aren't coming in. They're not being made the same in basic training. They don't come with the same enthusiasm. Everyone's always hurt and getting their feelings hurt. It's kind of like that these days with these new software developers. They just aren't built the same, right? And these are very basic questions that might be asked of you that you should know. So just be aware of this. Do you have any questions on that? Stress cards now. Is that a thing? Do they actually have stress cards? I don't know. I think I saw like a video of it a long time ago, like on Instagram, where people talking about like this is like an incident report or like a my being hurt report. But all right, let's go ahead and take our first 10-minute break. It's 6:39. Let's go ahead and come back at 6:49, and we'll continue with today's lecture. All right, let's go ahead and kind of start coming back. I think I'm gonna film you guys a minute. Oh, never mind. Right on time. Let's go. All right. Let's continue with the class. So we were talking about strings. And this should look a little bit familiar to you guys. I'm probably not even sharing. You know what I mean? There we go. I knew it. They should look a little bit familiar. I think JavaScript has very similar functionality, but it's just doing it here in Python that we're going to talk about. So we have our lists, right? And we want to do what we call a membership check, right? A membership check. Who can guess what a membership check is out of the name? Correct, right? If you want to check something in there, you want to see if if something's a member of something. You want to see if, let's say, for example, if is 5 a part of list 2, right? And to do that, we're going to use the in or the not in, which would essentially create some kind of membership check. We can say if 5 in list 2, print the number is in the list, right? Now, this is a very simple check, but we can essentially just use the in operator or the not in to conduct what we call a membership check to see if something exists within a list. Now, there's something that I want to point out about using the in operator on a list. Although it helps, what do you think the in operator is doing underneath the hood? You think it's just magic that it finds a 5 within this list?
It's about like running a loop.
Yeah, it's running a for loop, right? That's perfectly exactly what I was looking for, right? It's running a for loop, and that's important to know later on in the class when we start talking about the efficiency in your code. But although this looks like simple, like oh, I'm just gonna check if it's in there. In a list, the only way to find something in a list is either you know the index of the item, or you have to check every single item within this list until you find what you're looking for, right? Because of how it works with the sequence, right? It uses that index notation. If you want to find specifically if something's in there, no matter what you do, you have to use some kind of loop to figure it out, unless you know already the index exact, right? There is methods like list2.index, and then you look for like the letter or the number 5, right? Something like this. What do you think this is doing? A for loop, same concept, right? So you're able to find the index of stuff in different ways or find a specific number or something. But at its nitty gritty underneath the hood, it's all a for loop, right? And that's something to keep in mind when you're writing your code and you're thinking about is this efficient, right? Especially if your list is like a million different inputs. Is it really efficient to look for the number 374,516 out of a million entries to see where it's at? Like that sounds like very inefficient. How long would it take for your code to find this number? Not very good, right? So something to keep in mind. So we could use the in, or we can say something like not in. If 10 not in list 2, print it's not in here. And let's actually run this code because I didn't even run it to show you. But notice that it's going to check if 10 is not in the list, which it's not. So it should run this this print statement, right? So we can check if something's in there, or if it's not in there, hopefully it's going to run some kind of a for loop under the hood and find what we're looking for. we can also use something like define method, right? Define method, which is kind of like the index method. We can say list2 dot find, and I want to find 2. List object. Oh, this is more of a string. My apologies. I'm getting confused. Let's go with index then. Let's try index. Index of 2. Which should return 1. Yeah, correct. Right. So we're able to get the index of wherever this 2 is located at in a list. Right. But if we're working with a string, there's something very similar to that, which is using the find method. Right. So we have the list here. Well, let's talk about our animal string, which will be anteater. If we want to find a specific word within the sequence of characters, we can say animal dot find, and let's look at E. Right, we're gonna look at E. What do you think is gonna return to me? Oh, I did this wrong. Let me use this and then this. Fine. Okay. Get rid of this. Right, there you go. Right, and we get 3. Right, so the first time they found the E or it encountered the E was at index 3. Well, there's 2 E's here. Why didn't it show the first one? Well, that's just how the find method works. It's going to return the element of the item you're trying, or sorry, it's going to return the index of the item you're trying to find the first time it encounters it. So, just something to note. So you're able to check the index of something in a list. You're able to use a not in or the in operator. You can use the dot find method to find something within a string. These are just different methods of how to access things within a list or to check if something is in a list, right? And then finally, which I'm sure we've already seen when we're talking about for loops, but we can use the length operator, right? In JavaScript, we use dot length to figure out how long a list was. But if you want to do that in Python, you wrap the entire list with a wrapper, and the wrapper is called the len wrapper, right? So we use len, open parentheses, and then you add the item you're trying to look for, right? This will give you the however long your list is, the same manner that the dot length method in JavaScript work, right? This will not only just work on lists, but it also works on your strings, right? If we had, once again, that animal, which is the anteater, it'll work for both of these, right? We can print out the length of animal and the list, and as you see, they're both of length of 8. 1, 2, 3, 4, 5, 6, 7, 8. Right? The length method, when it returns to you a number, it's not referencing the index, right? It's referencing how many characters in total are there, right? It won't start a count from 0. All right, so just be aware of that. If you guys are not, aware of it, but unlike counting the spot or location of something within a list or a string, we start the count at index 0. When you want to get the actual length of a list, it won't start at 0, so it will start at 1. So you feel okay with that. All right. We have a couple methods that come with stuff like list, right? And just like everything else, you can find a large variety of different methods, but some very helpful ones are going to be stuff like min, max, sort, and sorted, right? So the first easy ones that you can kind of already guess is using the min, right? So minimum is equal to min of list 2. Now, what this is going to do, what the min method does, it takes in a list and it's going to look for the smallest number within a list and then return it to you, right? And which you can probably already assume what maximum will do. It'll take the maximum value within this list and return that to you. So we have some ways of doing this. Printing minimum and then comma maximum. And we can see that it should return 1 and 8 maximum. Right, 1 and 8. So we're able to get the minimum in a list or the maximum in a list. And then we're also able to use sort methods, right? So we're able to sort items within the list. Let's make a random list from random numbers that's not sorted. All right. Here is our list. The min and max still work. The lowest number is obviously the 1, and the highest is going to be the 9. But we're able to sort this, right? There's no specific order in this list. Well, there's 2 ways of sorting your stuff, and you can use the sort or the sorted method. Now, the way they use them differ, and it's something to keep in mind, right? I'm going to go print list 2. After I print it, I want to print list 2.sort, and you invoke this function right after calling the list you're trying to use. After I print that, I want to print out list 2 again, and let's see what that looks like. Let me comment everything else out. So I run the function list, all right, and it prints it out like normal. I then do print list 2.sort, and maybe this wasn't the best thing. It showed none, right? But what we can do is just get rid of this print statement so you don't see it. But when I call list 2 again, list 2 is now formatted, right? So it did manipulate my list, right? So it took the original list, it sorted it for me, and saved the new updated list into that list variable, right? So it updated the list for you. Now, there's another way of doing this, and that's using the sorted method, right? Where unlike the list 2, where you use the name of the list .sort, you call the function and then pass in the list as an argument, right? But this one has some different functionality. Let's look at it. I run list 2, which is not sorted, and then I use a sorted function on list 2, and then I print out list 2 again. But notice that list 2 is not sorted once I print it out again, right? When I ran the function sorted, what's going on? Well, let's print out what's happening. When I print this out, it'll sort it for me, but it won't manipulate my original list, right? So both of these will sort, but one will manipulate the original and one won't. The dot sort will manipulate your original list. If you wanted to use a sorted method to form a sorted version of this list, what you would have to do is reassign it, right? You will probably have to say list 2 is equal to sorted of list 2, and then it would work. Or you can create a whole different list like list 3. So you can keep the original, right? Let's print out list 3 here. And that way, list 2 still stays unsorted, but we created a sorted version in a different new list. So they both sort your list, but the way that they are used differ. Where sort will alter the input list and sort it, right? The original version. Sorted will make a copy of the list and sort that, right? Not affecting the original. So whichever one you use, it's going to be up to you and how you want to use them. But both can reach a very similar outcome. It's just a matter of how to reach that outcome. Does that make sense, guys? Right on. All right, let's move on. We're almost done with today's lesson for this. List comprehension. Are you guys familiar with list comprehension? All right. So it's similar to a kind of like a higher end function. All right. It's a little elegant, but it can look a little complex sometimes. I have a list here, right? And I can manually create this. I can say 1, 2, 3, 4. Right? Now, what if I wanted to create a different list where it takes every single item within this list and multiplies it by 2 and adds it to a new list? Well, normally I would do something like this, where I would say for num in list, and let's not just name it list because list is a reserved word. Let's say list 1. Just like in most languages, there are specific words that you don't want to utilize as variable names because these are what we call reserved words, right? These words have some functionality that are pre-built into the language itself. So you don't want to call it list, just list, or a string, call it string, or stuff like that, right? So for num in list 1, now if I want to create the second list where it takes the original input from the first one but multiply by 2, I would have to create this second list here and say list underscore 2 is equal to an empty list. And then I would have to run some functionality like this where I would loop through the original. I would grab the number and I would say something like list2 dot append, and I would append num times 2. Right? And then I can print out list 1 and list 2 and see the outcome of both, where I have the original, which is just 1, 2, 3, 4, and then I have the second one where it's the original numbers multiplied by 2. Now, this took me 4 additional lines of code. Well, list comprehension can help you avoid all this extra stuff with some very elegant functionality. Instead of taking 4, I can do this in an additional extra line, where I would say something like this, where I would say 2 times num. Now, what is num? Right? We don't really. It's almost like a for loop in one line, right? Where the first part you actually add what you want to do to the temporary variable, but then you actually have to declare what this variable is by saying for num in list 1. Right? Notice this is the first part of this for loop, right? It's already been highlighted for you, right? This will declare what you're trying to loop through and how you're trying to do it by creating this temporary variable. But then the actual functionality of what you're doing to each one of these variables is kind of on the left side of this. So it's almost like a little bit backwards, right? It's the same functionality that I added here within this for loop on one line, but the way that I call these are a little bit backwards, right? So I say 2 times num for num in list 1. And now when I print this, we will see that I get the exact same outcome, but instead of having to start a whole new for loop, I was able to do it all within one line inside of the actual bracket for this list, right? So list comprehension is a way to construct a new list, right, by applying some kind of transformation to an already existing list, right? And it doesn't even have to be an existing list. I can say for num in range of 1 to 10, right? And let's see what that does, right? And it starts a for loop in the range of 1 to 10. It grabs every single number and multiplies it by 2. So it doesn't have to be necessarily already an existing list, but you can give it a very specific range of numbers that you want to go through, right? Or anything that honestly that you can loop through in general, right? If there's something that you can kind of iterate through and grab individually, you can manipulate every individual item using list comprehension, right? So both of these work. One looks more elegant than the other, right? But one's a little bit more complex to understand. Now, what if I only wanted to grab even numbers, right? So let's go ahead and increase this list here from 1 to 10. And I want to create a new list where it's evens only, right? Well, how can I use list comprehension to do that? Well, I can say num for num in list 1 if num modulus 2 is equal to 0. Now, this might look a little bit confusing, right? But once again, I am trying instead of multiplying anything to the number, right? Instead of like earlier where we saw list 2 is equal to 2 times num for num and list 1. I'll redo it, right? Instead of actually multiplying the number that I'm iterating through, I'm leaving it by itself, right? I just don't do anything to it, right? This is going to tell my list comprehension that I want to add this number inside of this list. Well, what number is this? Well, it's going to come from the iteration of for num in list 1, but only if that num modulus 2 is equal to 0. So I'm able to do the same concept here, right, where I was able to loop through list 1, but instead I would say if num modulus 2 is equal to 0, then I would say list 2 dot append num, right? So you're able to do if else checks as well. So two different ways of doing this code using list comprehension, but both of these will allow you to iterate through some kind of iterable and then reach a certain outcome depending on a condition, or just no added condition and just manipulate the data itself. Do I have any questions on list comprehension? And none at all. Everyone good? No confusion here? Okay. Right on. That's all I like to hear. All right. Now let's talk about one of the last ones that we're going to talk about. And it's going to be dictionaries. Right? You guys know these as objects in JavaScript. Right? In Python, we don't call them objects. We call these dictionaries. And give me a small second. I'm trying to find the exact name of how they're called in JavaScript. I know I mentioned this to you guys before, but they're called differently in JavaScript. Yeah. Okay. So essentially, the same thing that you guys saw in JavaScript, where we had an object, right? And this object had key value pairs. You can do the exact same thing in Python, but we call it something different. We call it a dictionary, right? It works the exact same way using curly braces. We'll use the one in the example here. We're going to create state capitals, right? And to create this dictionary, we're going to use curly braces, right? Very similar to how we did arrays, we're going to do curly braces, but here it's pretty standard to, at the moment that you open up these curly braces, you go to the next line. Because of the key value pairs, it can be a little complex sometimes to kind of realize where a new key value pair starts. So it's easier to just declare it in this manner, right? The first key value pair that we have is going to be Washington. And the second one will be, or its value will be Olympia, which I don't even know if it is the state capital because I've never been to Washington, but I'm going to go ahead and assume it is. The second key value pair is Oregon, with Salem as its value. Then we will say Idaho, with Boise as its capital. And then Montana, with Helena as its capital. This just was an example, right? But as you see here, a dictionary is the exact same thing of what an object is in JavaScript. It uses curly braces and key value pairs, right? One thing to also point out is that it uses key value pairs, and the key has to be a unique value, right? It has to be a unique value. You can't repeat them because essentially, if you try to repeat the same key, it'll just override the previous one. Right? All keys in a dictionary must be immutable. So you can't leave a list as a key, right? it has to be something that's immutable. Strings are usually the easiest one to use because then you can also define what this should be, right? So the key itself should be an immutable data type, like a string. And then the value can honestly be whatever you want. It could be a string, it could be an integer, it could be lists or other dictionaries, right? Very similar to how JSON worked in JavaScript, creating your objects, where the value could be a list of different other objects, and these objects can have key value pairs with more lists and more objects, and next even further, right? But the biggest thing here is the key has to be an immutable type, and it has to be unique. Well, how do you access these, Roger? Same like JavaScript, we're going to use bracket notation, where we open up the brackets and then we call the key of the item that we are trying to reference, right? Let's go ahead and print this out. And when I print out, I get the value of the item that I am referencing, right? If I wanted to create a new item in here, it's as simple as calling the dictionary and just right off the bat declaring what it should be called. I can say Texas, right? It doesn't exist in here, but I'm gonna go ahead and declare that this new key will be called Texas. And what am I gonna assign to it? I'm assigned to it Austin. And I can't do this within the print statement, so I'm getting an error. But then I can go ahead and print state capitals. And now I can see that Texas was successfully added within the state capital dictionary. All right, so same concept as before. If you want to, set a new key value pair, you just call the dictionary or, in JavaScript, the object, give it the key you want to give it, and then assign it the value, and it will add it. Well, what if I want to delete something? Well, we can use the delete method just like we did in list. We can say del, call the dictionary, the value that I'm trying to remove. Let's go ahead and do Idaho because nobody likes Idaho. And by running this, we remove Idaho. Right, it's no longer present within my dictionary. Right. Any questions so far on dictionaries?
In JavaScript, you can do an if statement. Just says if dictionary name, dictionary value, and it'll return a Boolean. Can you do that in Python as well to check for content?
Yes,
And
you
if so,
can.
how?
That's gonna be the next part, kind of iterating through stuff and checking things in. But yes, no, you definitely
Uh,
can.
I mean, without using a for what in what.
Yeah, I mean, we could say if state capitals, Texas, print Austin is in this dictionary. This should work. Austin is in the dictionary. Yeah, same concept.
Can you do it as an example of something that's not in the dictionary?
Oh, yeah, let's go ahead and try if Florida, I want to say Miami. Is it? Yeah, if state capitals keyword error Florida. Um, else print Austin or Florida is not in here. No. Okay, so how can we do this without getting an issue? There is a way.
You could do it with a for in statement, but I was just wondering if there was a simpler way to do it like you could in JavaScript.
You could do something like this, and dictionaries are very powerful. I love dictionaries because dictionaries they use key value pairs to access things. Unlike lists, where you have to either know the index or iterate through the entire list until you find what you're looking for, you can just use a key to grab a set of values. You could also do something like this, where I can say state capitals dot get, and then I'm gonna add the key of the item I'm trying to look for. So you can use a get method. It's very powerful, right? It returns the value for key if key is in the dictionary, else default. So let's see what this prints out. print result. It's gonna print out Austin. So this will return to me by using the get method. I can grab something within here. But what if it doesn't exist? You say, let's do Florida. By default, it's gonna return none, right? Or what you can also do is you can give it you can override this default to return something like 0. So what this says is, hey, I want you to get the value of Florida, but if you can't find it, return 0 to me. And now when I run this, it returns 0. And
That's awesome.
it's pretty cool. I love the get method on dictionaries. You can do something else like it does not exist, right, as a return, and it would work, right? So you can handle it in different ways. You can do it the way we saw earlier, but you saw we got a message. So you can check, if we probably do something like this: if state capital.get is equal to, the value, or if equal to it does not exist, print I told you so.
You need a colon at the end of your if statement.
I do. Let's see if this works. What am I doing? Right. So we can check if we get the default of what happens when it doesn't find it. We can set this to 0 so it doesn't look all wonky. All right. Or if you don't even want to add anything, you can just say if Florida get is equal to none, print I told you so, else I want you to grab it. Right. So different ways to check if it's in there or not. Right. I think this is the best method because you handle the situation in the event it doesn't exist. Where you saw earlier when it couldn't find it, it gave you a key error. So then you have to add this into a try and except block. But the dot game method kind of really handles that. It's a very powerful method that you can use. You're going to be using this a lot in the cohort, I promise you. Does that answer your question, Tim?
You more than answered it. Thank you.
Right on. So just like JavaScript, once again, we're able to loop through our state capitals. Let's go ahead and say for state and state capitals, print state. What does this do? By default, when you loop through a dictionary, state is going to take the spot of the key, right? The key. And it'll print out the key. Or you can also do state capitals index state, and you can grab the value. So this is one way of doing it, right? But let's talk about the actual correct way, syntax-wise, of how you should loop through your dictionary. It should do something like this: for state in state capitals dot keys, right? To specify what exactly you are looping through. Sure, by default, it'll print out the key, right? But this will explicitly tell everybody else what you are looping through, right? I am specifically looking for the keys and I'm printing out the key. Make sense? This will give you the keys. We can also do for capital and state capitals dot values, print capital. We're able to loop through the values themselves just like in JavaScript. All right, so we can get the keys, we get the values, and for the icing the cake, we can say for state, comma, capital, and state capitals dot items. Right, where in JavaScript it's dot entries, I believe. Here, we can grab both the key and the value and utilize them as needed. All right, so we're able to loop through these the same way that we could in JavaScript. The only thing that changes is items is no longer entries, right? But you're able to grab either or. Do I have any questions on iterating over dictionaries? All right.
Real quick. So if I guess looking at the PowerPoint, if you didn't specify the dot items and you just ran for state capital, looks like you might have an error.
Correct. By default, if you don't add a dot keys, dot values, or dot items, it's going to iterate through just keys. All right. By default, it will go just through the keys. Make sense?
Mhm.
Okay, right on. All right, next thing we're gonna cover is gonna be tuples, and it's gonna be one of the last things we're gonna cover. Tuples are very similar to lists, but they're a little bit different in syntax, right? Tuples, the base thing about them is that they are immutable, right? They do not change. We can say some nums is equal to, and the way that you will essentially create a tuple is using parentheses. We can say 1, 2, 3. We can print some nums. We can print the type of some nums to see what it is. Let's also try to grab the index of one or something from this tuple. Let's try to change an index. Some nums, index 0 is equal to 3. Let's print out some nums again. So we got a couple things we're doing here to this tuple. But you notice that when I run the sum nums, which it prints out my tuple. I run the type of sum nums, and it tells you it's of class tuple. We're able to access something with the index just like lists, which is gives us the number 1, which is at index 0. But we get an error here the moment that I try to change the item in index 0 like you would in a list. And it says tuple object does not support item assignment. Right? So you cannot change a tuple the exact way that you would in um in a list. You cannot run methods like dot sort. You cannot run sorted, right? Because they are immutable. They are set in stone, right? The pro of a tuple over a list is the fact that they are easier and faster to access than a list item because tuples, since they are immutable, they don't change. So they have a strict address directly to each item, right? Tuples, because they don't change, they can be used as keys in the dictionaries because they are immutable as well. Do you have any questions on tuples?
Tuples can have multiple data types.
Yes, they can. Any other questions? You remember, why would I use a tuple, Roger? Well, a good example will be like a grid coordinate. All right, you want to get a grid coordinate for specific location? That's a good time to use a tuple. It won't change. Right? So tuples, to be complete for you, I don't use them often. I probably use them maybe once in my life. They're not always used. Lists are just simpler. You can pretty much do everything in coding as you've seen with variables and for loops and if else. Right? All these extra stuff, it's nice to have, but honestly, if you know just those things there, you can handle most of the things ever in code with just that. Mutability versus immutability, right? A mutable object can be changed after it's created, where an immutable can't. Right? You've already kind of seen that some items can be changed, some are not. Tuples, they're not changeable, so they're immutable. The lists are immutable; you're able to change them. We saw that. Numbers, they are, I believe, they're immutable. I'm pretty sure they're immutable. Num is equal to 5. I'm pretty sure we can say print ID of num. Num is equal to 6. Print ID of num. I'm like 99% sure. Yep, they are immutable, right? When we try to change it, it reassigns a different location. So integers are immutable. Dictionaries are mutable. These can change. Strings are immutable. These are just some of the more basic ones. But anything like I want to say like decimal, integers, strings, those are immutable, right? You don't change the original. You're essentially reassigning stuff. Those are your primitives. Stuff like lists and your dictionaries are much newer concepts. Those are changeable. When you use one or the other is going to depend, but it's important not really to know because it won't make too much of a difference for you when trying to redeclare a variable. But just to understand what's actually happening underneath the hood, so you can explain this to somebody else. Now we're gonna finish off today's lesson for lesson 7 using the count letters assignment. Right, we're gonna do this, immediately go into a break, and then we're gonna start the next lesson, which is gonna be object-oriented programming, because we should still have a nice hour of work. Now I know some of you guys have already done it, like Tim, but this should be a fairly similar one or simple one. You're gonna write a function named count letters that it's gonna take as a parameter a string, and is a returning dictionary that's going to check how many of each letter is in that string. Right, a string can contain other things other than letters, but only the letters should be counted. The string could even be the empty string, as in just something like open and close quotation marks and nothing in there. Right, lowercase and uppercase versions of a letter should be part of the same count, and the keys of the dictionary should be uppercase letters themselves. If a letter does not appear in a string, then it would not be added to a dictionary. For example, if the string is AABB, then you see here that both the lowercase and capital case A is treated as the same thing, so the count is set to 2. And B is treated the same thing as well, even though it's lowercase and capital case, they're both treated the same. So your final output should be a dictionary of A and B with the count of how many times that appeared. We have not covered its alpha, so do not use its alpha. Do you have any questions? All right, give this 10 minutes. And then go into a 10-minute break, and we will come back at 7:50. Do you have any questions? All right, at 7:50, we'll take a quick demonstration, and then we'll jump straight into object-oriented programming for the remainder of today. I'll see you guys in a bit. Let's go ahead and start coming back, guys, from break. Let's get a volunteer for the count letters.py. Jason, you want to volunteer?
I can, but I wouldn't mind if somebody else did. I mean, I did it, but I'll give somebody else a chance.
I'll
This
do
is
it if
the
you want.
last one.
If Kenny doesn't want to do it, I'll do it.
Penny, would you like to volunteer? You haven't volunteered for any of these recently. Are you good? Okay. Jason, I would like to see yours, Jason. I feel like Tim always volunteers. Is that okay? Even if you didn't
Yeah,
complete it, like
yeah,
we
yeah,
can work
yeah,
on it
yeah,
together.
yeah. I'll show you. You see my screen? Do you hear me?
Yes. I'm
Okay.
sure you probably
So
can't see my camera.
I'm sure there was an easier way to do this, but I essentially just created a string with all the letters capitalized. And then I assigned a variable with string with all letters capitalized, created an empty object. I looped through capitalized, which was pretty much all of the letters in string capital. And if the letter is in result and letters in alpha, add a letter. If it's not a key, but it's a letter, then assign a value of 1, and then return the result, or essentially return the object at the end. And I'll prove that it works.
Put a space.
I'm sorry?
Put a space in your string.
What do you mean?
Put a space in your string. Somewhere. No matter. In line 24.
Okay. Oh,
Anywhere here. Put a space. Put four
notice.
spaces. Put it in between your words. Somewhere in here.
You're talking about just like this?
Yeah. Do you want to see?
Oh, I don't know. We'll see what happens. Okay, still works.
For letter in kappa, letter in result dot keys. Okay. And letter in alpha. All right. Looks good to me. Anybody have any questions? Right on. Good job there, Jason. Appreciate your time. Let's go ahead and move forward with today's lecture. We're going to go ahead and close off this chapter. We are done with the Python crash course. Let me share my screen. That was the last assignment for the Python crash course. We were able to move on to lesson 8, which is going to be classes and objects. So we're not shifting away from Python, but we are no longer just specifically just talking about, the crash course itself. Now we're going to talk a little bit more specifically about what classes and objects are, and how we can use Python and classes and objects to make reusable code that's well structured and organized. Now, what is a class, right? I'll give you a couple different analogies, but a class is essentially a factory for creating a new object. The term I like to use is blueprints, right? I like to think of it as the blueprint for creating an object, right? It's a way of organizing your code. Class objects can be used over and over again, so it's also a way of keeping your code dry or don't repeat yourself, right? The picture here that you see is a class of a car, right? Once again, the blueprint of a car, right? Let's think about a car. What do cars have, right? Well, this class or this blueprint for this car should have a color. It should have the make, the model, fuel type, as well as some additional things, right? There's obviously many other stuff that goes into making a car, right? But there's some basic stuff to kind of get the point across. Now, this class here, which is once again like the blueprint to create a car, we can use this class to what we call instantiate an object, right? So classes and objects that go hand in hand, but they're not the same thing. The class is like the blueprint, right? Think of it as defining the function, right? That's what the class is. You are defining the blueprint, creating like the recipe for something, for whatever object you're trying to create, right? And then you use this class to instantiate, to almost like bring to life an object, right? Create something out of the class, right? So they use this class, this blueprint, to then in turn create an object, right? And using this blueprint, we can create different variations of a car, right? And you can see that here with the 3 different objects. The first one is a yellow car. That's the make of a Ford, model of a Mustang, and it takes gasoline, right? Then we have a different version of this class in the form of this object here. That's a red Toyota Prius and a hybrid, right? Same thing with the blue Volkswagen Golf and diesel. These are 3 individual unique objects, but they all derive from the same class, right? They were all created using the class. Does this make sense with you guys so far? Is this the first time that any of you guys have been learning or have learned about class and objects? Is this like a new concept? I just want to make sure so I know how thorough I have to be about explaining this.
I've had some exposure, but not a lot.
Okay. Tim? Kenny?
These like constructors in JavaScript.
Okay. How about you, Kenny? How comfortable are you with this subject? Okay, Kenny says first time. Sorry, I had to walk away. Thank you, Kenny. All right. Yeah, so I only asked so I know how thorough I have to be about the explanation. So I know kind of the level of knowledge of the audience. Regardless, I'll probably still be a little bit thorough because you know, I tend to like, but within like 24 hours of showing these videos, there's like 20 views already. So it's not just you guys who are seeing these videos, but there's other people that are checking this out. So I want to make sure that everyone that is watching our content is understanding the material. Now, the class syntax, right? Like the function, we use the DEF for define. Classes have a very unique way of being defined. And you guessed it, right? It uses the declaration of the keyword class, right? Let me go ahead and break away from this real quick and move this to the side. And let me go ahead and shift over to this new directory, which I recommend every single one of you guys do. All right, we're gonna get some coding. This is not something that you can kind of just watch. I highly recommend. I need you guys to code with me, so you're not confused. All right, we're gonna go to lesson 8, and then just make a new file. Right, a new file that we can kind of we'll go through and write some notes and just run to test out. This will be classes and objects.py. All right, let me make this real quick. Touch class and objects.py. And then, yeah, I have it here. Okay, cool. And then let's go ahead and open it up. And let's talk about the syntax. So as you saw in the slides, right, the way that we declare a class is by using the class keyword, right? And now the naming of the class is actually very different than how you would name a Python variable, right? You guys have been used to something like, you know, my name, right? And it was like all lowercase spaced with a underscore. The way that you name classes is you want to capitalize every word, right? So this would be, for example, if we were trying to create a class of a pet, it would be capital P for pet, right? If you had like, let's say, like user login, if you had a class called user login, every word would be capitalized, right? So there's a very specific syntax for how to write it. You might use some other people, see other people do it differently, which is not, it's not gonna fail, right? But typically classes are capitalized per word, right? Now, the classes we have, they're gonna be very simple, but normally you can inherit, right, from other classes. And when you inherit from another class, you would open up some parentheses, but we're not gonna get there yet, right? But I'm bringing this up in case you see like examples of classes out there, and after the class name you see parentheses. That's if you want to inherit from something else, which we'll get to in a bit. But you don't need to inherit from anything. You can create a simple class just like this, class pet, right? And then once you start with this definition, you go into the code block, right? You press enter, you add that colon, and you press enter. And then everything afterwards is going to be a part of the class, right? Just like everything else that we saw when defining a function, starting a for loop, if else check. The moment that we got ready to go into a code block, we use the colon, enter, and then it would indent it for us. The moment that we are done defining this class, we just unindent, letting our Python file know that we're done defining this class. So with the definition, or the declaration, I apologize, of our class, comes the very first method that you guys need to know, which is called an init method, right? Which is an acronym that stands for initialize, right? An initialize method. Now, what is this init method? Well, this init method is the method is a fancy way of calling a function, right? Classes have what we call methods, right? But it's pretty much just individual functions, right? So they're going to be created the same, but they will have a little bit different in the syntax. But methods are just another fancy word for functions. They're called methods because they belong to a class, right? So when you use these functions within a class declaration, we call them methods. But they're in essence, they're essentially just a function, right? And the first function that your class needs to take is the init method, right? Which is a function that your class is going to use to create itself, right? This is where you're going to define what this class is, right? So just like how we define a function, we're going to start with the def, right? To define this method or this quote unquote function, right? We're going to define this method, and then to create an init method, this is very specific. It has to be written this way. You need to use double underscore, type in init, and then double underscore. This is what's known as a dunder method, right? Which is short for double underscore method, right? This is a dunder method. Typically, dunder methods are default methods that come with a class that are used to define certain properties or attributes for the class, right? This init method is standard when creating a new class because this method is what's going to define what this class is, right? So when you create an object by using the pet class, the pet class is automatically going to run your init method. And everything that's set within the init method is what it's going to take in to be itself, right? After you define the name of this method, which is supposed to be a dunder method, you're going to open and close parentheses, right? And just like a function, it's going to take some parameters. The very first parameter that every class method will have is going to be self. Now, self is probably the most confusing thing to kind of understand. But self is standard for a class to have. It uses this keyword self to know that it's going to call itself. I honestly really suck at this part about explaining what self is. But just know that because this is a class, it needs to know that that this is a class method, so it needs to call itself. And maybe it'll make a little bit more sense as we continue, right? But the first standard and default parameter it needs to take is going to be self. And you'll see this with all the other methods as well. It needs self. And then we'll see what happens when we don't add self, right? Now, after you add the default of self, then you can start giving it its kind of functionality or its attributes, right? Well, this is a pet. So what should pets have? Well, for one, they should have a species, and they should have a name. Right? We'll keep it fairly simple. So this pet's attributes are its species and its name. And just like a function, right? Because that's what this method is. It's a function. We're going to start with a colon, and then we're going to go into the actual definition of this init method. Now we have to set these parameters to their respective attribute. So we have to create these attributes. Attributes is essentially good. They're variables that belong to this class, right? And the way that they are declared is by using self, right? It uses this argument as being passed to this function to say, hey, me, myself, I'm going to have this attribute. And the first attribute I'm going to have is going to be self.species, right? That's why we need self, so it can refer to itself to say, hey, this is my attribute, right? Afterwards, we assign it the attribute it's supposed to have, which is supposed to be the species parameter that's being defined, right? So now this pet knows whatever gets passed into this argument is what I'm going to assign to my attribute species. And the same thing for name. We're going to say self.name is equal to name. Right? This is going to create, this init method is going to create an object with the attributes of species and name. Now let's go ahead and instantiate this. Right? We can unindent out of here, and we're going to create a pet. I'll call this my first pet. And to create an object, you have to call the class. So it knows what class it needs to use to instantiate an object, right? So we start with the name of the class and open and close parentheses. Take a wild guess what you're going to add in these parentheses.
The species and the name.
Correct. the attributes are going to belong to this object. So this is going to be a dog, and his name is going to be Oliver. Right? Now I'm going to print out my first pet, and it's going to look a little weird, and we'll talk about it. I'm going to go ahead and run this. I'm going to say Python classes and object.py, and then we get something here. We get main.pet object at some weird code here. Now, this is the default print statement of a class, and we can figure out a way to override this. But what this is telling you, right? But it's default, even though it's a little unreadable to us. We don't know what this code is. This is its memory location. But this is what you should get when you try to print out an object, right? This is an object. If you want to get something a little bit more readable, you can say print type and then the object. And you see here class main pet, right? So this is an object of pet. Make sense? The init method, the moment we call this pet class, it runs the init method by default automatically, and it uses the arguments that were passed in within the init method to create these attributes. Now that I have this pet, I can access its individual attributes. I can say my first pet dot dog. I'm sorry, not dog, my apologies. Dot species, where we have to call the attributes that we're trying to access. Let's go ahead and shorten this. And then let me print this out so we can see it. But I'm able to print out its attributes and see that the species of this object is a dog. And I can do the same thing for the other attributes. Print my first pet dot name, and I can get the name of this object. All right, so we're able to access these attributes by calling the object and then using dot notation to specify the attribute that I'm trying to call. Do I have any questions on this so far? All right. So we talked about declaring a class, the syntax it takes. The init method, here's a different example. The init method does not need to take parameters for every data member, kind of like a function, right? It depends on whether it will always be initialized with the same value. So here we have two examples. Now, this might seem a little overwhelming, but we'll talk about the first example on the bottom. Actually, we'll talk about the first one. Look at the class of the example here. It's called non-customizable robot, right? This is some kind of robot that you have no ability to update its attributes, right? This init method, it only takes in self, nothing else. Notice that you do not have the option to pass in any arguments when you create this non-customizable robot. By default, the moment you call non-customizable robot, open and close parentheses, it's going to automatically create some kind of object with these attributes already set. We hard-coded these attributes, right? We hard-coded for it to initialize an object without accepting any parameters. By default, sensors is taking in a list of different sensors. It has gyrometer, LiDAR, and a camera. Right? It has some other attributes, actuators, name, state, and these are hard-coded in here, right? Let's see that as well. We're going to code it out so we can kind of print them out as well. We're going to say class non-customizable robot. I'm going to define the init method, and it's not going to take any arguments, self, right? But when I declare its attributes, I'm going to hard code it. And now you might see something like, Roger, why are there underscores right before the name of the attribute? Well, this is a specific naming convention that we use in classes to specify a attribute that should not be manipulated by other people, right? This, in short, it makes it private. And we'll talk about this in a little bit. Just know that it's making this a private attribute, and we'll elaborate a little bit more on that. But I'm going to hard code the gyrometer, the LiDAR, and the camera. I'm only going to do a couple attributes because I'm not going to waste time on all these. Let's go ahead and say that it's going to have name and it's equal to data. Well, let's go ahead and create this robot. Robot 1 is equal to non-customizable robot, and that's it. It doesn't take any parameters because we did not give the init method the ability to take any parameters. Right? Let me go ahead and print robot 1. And I can see here that it did instantiate an object of this non-customizable robot. What if I do robot underscore 1 dot underscore sensors? And this is a little roundabout, and I'll explain what this is in a bit. But notice that I'm able to grab the sensors, and I'm also able to grab the name. Right? So even though I didn't give this attribute within the parameters, by default, when it instantiated this, the init method created these attributes itself. Right? So the init method doesn't always have to have an attribute. You can, an attribute passing the parameters, you can just default them to be something very specific. Right? So we have the non-customizable robot, and then we have the customizable. And I realize that I misspelled customizable. That's okay. But here, we would add sensors, we would add actuators, and we would say, let's say, just sensors and name to keep it simple. Self.sensors is equal to sensors, right? And then self.name is equal to name. And now when I want to create robot 2 using the customizable robot, I actually have to pass in the parameters, which will be a gyrometer. I'm just going to pass in 1. And then the name will be, I'll just say Alice. Right? And then I can print out robot 2 dot underscore sensors. And it prints out gyrometer, right? So you can have the ability to customize your class or to not give the option of customizing it and just have a default value. Self refers to the object as in I, right? So, hey, myself, I'm going to have sensors, which will be this, right? That's kind of what self is referring to. Do you have any questions on the init method? All right. And just like functions that you're able to give default values, right, for specific things, you can do that. You can say name is equal to Bob. And in the event you don't want to always give it a name, there should be some default value. You could do that, right? Notice that when I create this customizable robot, I didn't pass in that second argument for name, but I'm still able to get the name afterwards because by default, it was set to whatever name is, which is default of Bob. So you are able to give defaults here as well through the parameters. In the event you want to make it customizable, but if they don't want to make it customizable, they don't have a default value. So you can give them the option to have the ability to override it if you wanted to. Any questions? Now, let's talk about this underscore before I move on so you guys are not confused. There's 4 pillars of object-oriented programming, which we're not going to cover because it's out of scope and you'll talk about it within the cohort. But the 4 pillars, if I remember correctly, is going to be abstraction, encapsulation, polymorphism, and I want to say inheritance are the methods or the pillars. And these pillars are kind of what represent of how you build classes, right? Now, what these are mean different things, but let's talk about encapsulation. Encapsulation is essentially, in a way, the ability to bundle up data and restrict access to some components, right? Now, if you're familiar with Java, which I already know you guys aren't, when you create a class, the syntax is a little bit different. It's something like this, where it's like class, private, customizable robot, right? Something like that. But you have the ability to add something like this, where you add a setting to your method or your class, where you make something private. And what that means is when someone tries to use your class, they're restricted to some of the things that they have access to, right? Java has this functionality. Python does not have this specific functionality. So there's a way to kind of make things private, but it's kind of like a roundabout way of doing things to keep people from directly accessing certain things that you don't want them to manipulate. Even though Python doesn't natively have this functionality. And what people discovered was if you add underscores before the names of certain attributes, you can make them private. Now, I believe the standard is 2 underscores. Some people just use 1, but to make it like really, really private, you kind of want to add the 2 underscores. So when people try to use something like robot underscore 2.name, it won't work, right? And say customizable robot object has no attribute name, right? Technically, they can do something like underscore name, and then they can access it. Actually, oh no, it doesn't. Customizable object has no attribute underscore name. But this is kind of like the way of how we would make something private so people don't have direct access to. And that's in the event you have an attribute that's, someone shouldn't be able to manipulate themselves, right? What if we have something, and this is just a quick example, like class bank account, right? And this bank account has an attribute of account balance. Should someone be able to come into the code and be able to manipulate their account balance? Probably not, right? So when you define this, you want to say self.__ account balance is equal to account balance, right? So there's certain things that you might not want somebody else to have easy access to when working with things, right? So you do this to privatize certain attributes to prevent people to just easily manipulate things. Make sense? And that's one of the pillars, which is encapsulation. We'll talk about the other ones as we go through them. I'm not going to go too deep into these. These will be taught throughout their cohort, and they're not really needed to kind of understand everything. But I'll just give quick descriptions of certain things as we go through. Make sense?
I guess what's the point of even having like a single underscore if it doesn't really do anything? Like if you need two, like I see the
Yeah,
point of having zero so it's not private and two so it's private, but just having one doesn't seem to really mean anything at all.
yeah, and I think recently it changed because it used to not work at all. The 2 underscores. So I want to say it's probably like a recent change because I remember last time I was a little surprised when I did that and it didn't work. Because I've taught this class for a while now and it's worked in the past. So yeah, I guess the new way would definitely be go with 2 underscores to ensure something is private. Does that make sense? Yeah, but definitely I would say moving forward have 2 underscores. I don't know if the curriculum for the cohort has changed. And I say that because whenever you run your tests, if the test only has one underscore and you're trying to do something with something and you didn't do it the right way because you're so used to double underscores, just be aware of that. Maybe the curriculum might not reflect, and that might be an issue you might encounter. So I don't know how the curriculum is right now, just giving you a heads up. But yeah, so that's kind of what the underscore is. Now, let's go ahead and continue with the lesson. Instantiating a class, we kind of already talked about it a little bit. Here is the pet class once again, right? The same thing that I was able to define on my VS Code. It has species and name, right? They kind of privatize the species and name so people don't have direct access to it afterwards. But notice they were still able to access it even though they used the underscore here to grab it. Now, what are these objects? The class objects that are made are just containers for storing data and functionality, right? These objects have properties like name or species, but they can also have methods that do things. And this is where it gets pretty fun. All right, so I have, let me go ahead and delete this. I had this pet class, but besides the init method, you can add an abundance of other functionality to this class. We can create a class where it's like define bark, right? And it will take itself just like everything else. And all you say is print bark, bark, right? Now, we can say print. Actually, we don't have to say print because it's already in the method. We can say my first pet dot bark, and we can make this kind of this object, quote unquote, actually do something like bark, bark, right? By calling the object and the method that we define, we're able to make our class do things. Right? We can have it be very specific to other things specifically, which we'll get to later. But you can make it do things like this, where we can say bark, bark, right? Do I have any questions on this method? Well, let's talk about this item that we got whenever we printed it out. When I say print my first pet, I see this weird little hash that doesn't really mean anything to me. Well, this is a default version of what happens when you print out a object, but there's a way to override that. And that's by overriding the dunder method that handles this. This dunder method is the double underscore string method. And by overriding it, we can make it say something else, like return, my name is self.name. And when I run this, instead of giving me that hash, right, I override the response that I'm supposed to get when I print it out to tell me something that's very specific to this class, right, where I can have the object tell me its name. And when I make another pet, like Whiskers here, and I print both my first pet and my second pet, it'll take the name that belongs to that specific object and it'll print out something unique to that object. So there is a way to override that if you want to understand what your object actually is when you print it out, right? This is another dunder method that you have to your ability. There's other dunder methods, but you don't really need to know all of them. This is a very common one, which is really going to help you out debugging and seeing what your objects are. If you want to get a very specific response when you print it out to visualize what object this is. Right, so do I have any questions so far before I move forward?
Instead of replacing that using the dunder method string, could you concatenate to add the name of the pet after main pet object and memory address?
Uh, that's a good question. I'm not quite sure how I would do that. Um, yeah, I don't even know how I would do that. I would have to look that one up, Tim. I've never tried it, and I don't even know how I would do that. I'm not used to finding the memory address for the class. I'm sure there probably is a way of doing it. This just completely overrided it.
It wouldn't just be ID again, like the ID method.
I don't know how that would be done. Maybe like uh I don't think type of self will work. Oh, right on. I mean, this doesn't give me the actual ID, but let's go ahead and switch this to ID. There you go. That's one way of doing it. I've never tried it. That's a good question. Right? And see how you can use self to call it upon this class of what it is. So that's why self is really important. That's what it used to talk. It's almost like talking to itself in third person, right? It's kind of funny. But that's a good question. All right. So we talked a little bit about private data members, right? So some languages have a keyword private. That means certain data members or methods can't be accessed from outside the class, right? So because Python does not have a native keyword for that, we use the underscores, right? Which you kind of already saw an example of when you want to do that, right? You don't want people to manipulate the count ID or balance because you can do something like this where you can say my first pet dot name is equal to uh let's go with Alex. And then when I call that, you see how I was able to override the value of that data member by just calling the attribute? You're able to do that. So to keep people from doing that, you want to privatize it. Does that make sense? You want to keep them from accessing data members that they should not be messing around with. There's a way that you want to kind of give them the ability to do stuff if they're private, right? And that brings us to the next conversation, accessing private data members. So notice that in our big account class that we have specific methods that set the values of certain data members. So here we see that account ID and account balance are private, quote unquote, right? But you don't want them to manipulate it directly, right? You want to be able to give them access to certain attributes that you do want to manipulate, right? And not every data member should have this ability. You can pick and choose how you want to do it, but you can create a method. Notice here that it's called get account ID. This is what we call a getter function, right? A getter method, right? We have what we call getters and setters, right? Getters allows you to let people grab information that's private so they can see it but not manipulate it, right? And this method here, it's going to grab the self dot underscore account ID and return it, right? But it won't allow them to manipulate. They can use this function to grab the item to see what it is, but they won't be able to manipulate directly. That's your getter method. And then you have your setter methods where instead of returning it, as you see here, you're going to set it to a new value. The setter methods will take a parameter, unlike the get method that takes nothing. It just returns to you a specific data member, depending on what that method should be doing. The set method will take in a new value and set this to that new value, right? And we can see that with our pet class. Let's remove this. I'm going to privatize species and name, right? And I'm going to create a get method to get species. So define get pet species, get taken self and nothing else, and I'm going to return self dot underscore species. And now I can say my first pet dot get pet species. And I need to print it out, of course. But here I'm able to grab the species, but they're not allowed to change it, right? I can't do my first pet dot name or dot species is equal to a bird, right? They shouldn't be able to do this. Let's do it again. Print my first pet dot species or get pet species. And it, you see, it doesn't change, right? So we should be able to give them access to certain data numbers so they can see what it is, but not specifically update it. So we can privatize data members, give them access to view it, but not actually manipulate it, right? This is what is called a getter method, right? Where we get certain attributes. Now, we can do the same thing for the name. Get pet name, which will be self, return self dot underscore name. Print my first pet dot get pet name, and we can grab it, and we get all of them. Well, pet name is probably something that they should be able to change, right? Let's say a dog was given a specific name for 2 months when it was first born, but it was adopted by a new family, and they want to change the name in the registry before they adopt them. So we should be able to set pet name. It's going to take in self, and then we can say something like new name. And what this is going to do is going to access the name attribute, and it's going to set the new name to that parameter is being passed in as an argument. So after we get the pet name, let's go ahead and say my first pet dot set pet name. And it's going to be Max. And then let's go ahead and grab that pet name again. And we can see that at first he's called Oliver, but we use our registry to go ahead and change the name of the animal for the documentation as they're adopting it from our shelter. And they're able to change it to Max, right? And this is what we call a setter method. Right, so we have ways to privatize data members, ways for them to grab data attributes that are private, and then there's ways of how to manipulate and set new values to these specific attributes. Right, and once again, I have to harp on the terminology. These are called data attributes, or data members is another way of saying it, but they're attributes to the class, right? The data attributes. So when I say data attributes, I'm usually referring to the attributes that are defined within the init method. Make sense? Look,
So
any questions?
Yeah,
Yes.
the getter and the setter methods are only called that because you literally call them get and set. Could you call them something else and they would still work as getter and setter methods?
Yes. They would, whatever you want to call them, but my
But it's
naming convention is that way because it's more understandable. Like, oh, what should this function do? It should
yeah,
probably grab a get species, right? So
totally makes sense.
yeah. I kind of already went ahead, but printed objects of a user-defined class. So we saw earlier what happened when we printed out an object and it gave us this weird hash, which wasn't very useful to us as developers. So we essentially just override it using the their string method. It says later in the course we'll cover how to redefine the behavior of the print function, but I already showed you. It's a very quick example. And here's a quick little meme about objects where like everything in Python, like it's all objects. It always asks me, right? All the functionality that Python has, it's essentially a bunch of classes and objects in the background. But that's how it was built, right? Most of your code that you will write for the rest of your time actually in the program is going to be a lot of classes. So you have to get used to working with classes and objects. because it's a great way to format and make good readable code to reuse. And it's just very helpful, right? This is what's going to be used for your first assessment. Now let's get into an example for today, and this is what we're going to use to finish off the class. We're going to talk about a taxicab.py. Just check it out. It's an empty py folder, but let's look at the README. You're going to write a class named taxicab that has 3 private data members. One that holds the current x coordinate, one that holds the current y coordinate, and one that holds the current odometer reading, right? Remember, we're talking about a taxi, right? The class it's a taxi, and the x and y coordinate is going to represent the location of where our taxi cab is, and the odometer just reads how far it's moved, right? An odometer simply measures the distance a car or bicycle has traveled by keeping track of how many times its wheels has turned. So if you travel 1 unit left and then 1 unit right, you'll be back where you started, but your odometer will tell you that you traveled 2 units. All 3 data members should be updated as needed so they are always current, right? The class should have an init method that takes 2 parameters and uses them to initialize the coordinates. It also initializes the odometer to 0, right? Because it's going to be a brand new cab straight out the workshop. It should have a method called moveX that takes a parameter that tells how far the taxi cab English is hard. That the taxi cab should shift left or right. It should have a method called moveY that takes a parameter that tells how far the taxi cab should shift up or down. Right? X, if you guys remember math and graphs, X is usually your left to your right, right? And your Y is your vertical axis that represents up or down, right? Now, depending when this moves, if you move your X or Y coordinate, then your odometer should probably reflect. And this is how it should look like. You should be able to instantiate a cab at a specific grid coordinate. It calls the move X method. It takes in a unit of 3. So it moves the cab 3 units to the right, right? Because it's a positive number, right? X being the horizontal axis. So a negative number will move it to the left, and a positive number will move it to the right. Then we have move Y with -4, right? The Y axis is the vertical axis going up and down. So a negative unit will move it down, right? And so on and so forth. Notice that they run this method 3 times, both X and Y, and then they print out the get odometer method, which will print the current odometer reading. Right? At this point, the cab has traveled 3 units when it moves to the right, 4 units when it moves down, and then 1 unit again when it moves left to on the x-axis for a total of 8. Right? So this will be the new coordinate reading, but it should have an odometer reading of 8. Right? Does this make sense? Does anybody have any questions? All right, this is going to be the only assignment we get to work on today, but it should get us kind of started. Time is 8:41. Let's take to 8:55, and then we'll come back and get a quick little demo before we cut for the rest of the night. I'll see you guys in about 14 minutes. There we go. All right, so I'm going to go ahead and open up this to the side so I can visualize what's actually happening with my code. And let's go ahead and kind of code this out. We have to create a class called taxicab, right? So we're going to say class taxicab, and it has 3 private data members, right? So we're going to define our init method. The data member should be a X chord, or let's say self, X chord, Y chord, and then that should be it, because the odometer is supposed to be set to 0 the moment we instantiate this, right? So we don't need to specifically pass the odometer in here, because it should be instantiated to to 0, right? And we see that here that class should have an init method that takes two parameters and uses them to initialize the coordinates. Right, so we should say self dot, and we're going to privatize this. So we'll say self dot underscore underscore x chord is equal to x chord. And do the same thing for the y chord. And finally, we'll set the odometer to 0. Right? So that takes care of the init method. It has the two private data members, one that holds the current x, one that holds the current y, and then one that holds the current odometer reading. Now, the class should have get methods for each data member: get x chord, get y chord, and get odometer. So let's go ahead and create this. We'll say get define get x chord self, and then return self dot underscore x chord, and then do the same thing for all the other data attributes. Self dot y chord, and then get odometer return self dot underscore odometer. Right? It takes care of the second part. Now you should have a method called moveX that takes a parameter that tells how far the taxi cab should shift left or right. Right, so we'll call define move x and itself. And it takes a parameter that tells how far the taxi cab should shift left or right. So we'll say new x. And then depending what this new x is, we need to update our current x coordinate. So we should say something like self dot x chord plus equals new x. I believe what we want to do, and we'll experiment with this in a little bit, but we want to essentially change what our current x chord is. So if this is 5, and then we move it 3 units, if we plus equals, depends whether it's a negative or positive, it should reflect the correct way, but we'll mess around with it. But after it moves, we also need to update our odometer, right? So we'll increase the odometer by the new x. And then this has to be absolute, right? Because the odometer isn't going to go down. So whether it's a negative or positive, it always has to be positive, right? Because we have to increase our odometer. Unlike the x coordinate that should be able to go up or down. And that takes care of move x. Now let's go to move y, which will be self, new y. And this one should update our y coordinate with the new y. And then once again, update our odometer with the absolute version of what the new y should be to increase the odometer. And I think that should conclude it. Let's go ahead and create this cab. We'll say cab is equal to taxi cab. We'll use the example of 5, -8. Right? We'll say cab dot move x by 3, cab dot move y by -4, cab dot move x by -1, and then let's print cab dot get odometer and see what it looks like. I'm going to see Python, or let me cd into the file or the directory, and we can run Python taxicab.py. And I see here the odometer does give me 8, right? So it did work correctly for the odometer, but let's go ahead and print out whatever the y is and the x. And these are all methods, getter methods. And we see it reflects 7 minus 12. And that concludes the cab example. Do I have any questions about the taxicab.py?
Yeah. So I had done all of those things. But when I run my file, I'm getting an error that says bound method cab.getOdometer of less than main dot taxi object at memory address.
Well, hold on. Give me a second. Let me go ahead and stop the recording. That's going to conclude today's class. I'll answer any questions out of camera because I don't want to just keep anyone here that isn't able to stay here. For those of you that do need to step out right now, you guys are free to go. Thank you guys for showing up today. I really appreciate your hard work, and we will continue this lesson tomorrow.